Now we've understood the impact of flow time interruptions on capacity, in particular how setup times required between different types of products decrease capacity. We also understood that processing in large batches brings our capacity back up, but means we need higher levels of inventory in our process. Now we want to understand a best practice metric, the overall equipment effectiveness, or OEE, which is used to measure such flow interruptions, and in addition, process defects by measuring both capacity and quality losses in a system. The learning objectives are to describe the three components of overall equipment effectiveness and how they impact productivity, to list the 6 main groups of OEE losses, and to calculate the OEE from production data by calculating the availability rate, the performance rate, and the quality rate. We also want to understand how OEE is a relevant and useful metric in lean production. This lecture is based on our course offered here at the Technical University of Munich. Overall equipment effectiveness is a key metric and tool to manage machine-intensive production processes. OEE is a measure of system productivity, how available your process is, how fast your process is, and the quality of your process to produce defect-free parts. If your OEE is 100%, it means that you manufacture only good parts. You manufacture them as fast as your process can process with no stoppages. OEE is calculated by determining equipment availability rate, performance rate, and quality rate, and is calculated by multiplying these 3 rates together. The availability rate is the total available equipment runtime, production time, divided by the scheduled runtime, this time that is actually planned for production. So the availability rate is a measure of equipment stoppages, and these can be both planned and unplanned. And again, an availability rate of 100% means that our process is running every minute that production is scheduled or planned. And we look at this in more detail in the next slide. The performance rate measures the speed of the process. And this is calculated by taking the production time that is actually used for producing parts and divided by the available production time. So a performance rate of 100% means that our performance is producing parts as fast as possible in the time that is available without any stoppages for production. The quality rate is a measure of quality losses, so any defective parts that do not meet the required specifications. Now this is actually normally calculated, as we've seen in the previous courses, by taking the number of good parts divided by the number of total parts produced, or our yield. But in our OEE language, we consider this as the effective production time divided by the actually used production time. So the effective production time to produce good parts divided by the time that's actually the total time that's used to produce all the parts. Now, OEE, as we said, is the product of these ratios. So just one note, OEE means that we're considering availability, performance, and quality all with equal weight. OEE losses can be categorized into 6 main groups. The availability rate is reduced by losses due to downtimes. So this can be breakdowns or machine failures. Now, it can also often include actually maintenance, no, not a failure, but the time needed to perform a maintenance. And generally, this is the times for this type of stoppage is something more than 10 minutes. Setup times, as we saw before, are also considered in the availability rate. So any setup or changeover that's necessary where the machine is not able to produce. The performance rate is affected by speed losses. For example, stoppages that are generally less than 10 minutes, so smaller, minor stoppages, not a breakdown, not a maintenance, a large maintenance. And here it's important to note that these small stoppages can actually add up to a very large loss. Reduction in performance rate is also due to the operating speed, and what we mean here is if a machine is actually running slower than its capacity would allow. This could be because we have a bottleneck somewhere and the machine has to run slower to meet the bottleneck rate, or as we learned in the variability lecture, when you have queuing where material has to wait to be processed, so the machine can't run as fast as it would like to because somewhere in the process the material is waiting to move on. The quality rate, as our last component, is reduced, of course, due to quality issues. So any defects in the process that mean that we have to rework or scrap parts. And here it's important to understand, any parts that need to be reworked or scrapped, first of all, we've lost a lot of for the scrap parts, we've lost the capacity upstream. We've lost the material and we've lost the time that we needed to produce those parts. For rework parts, we have to put in additional manpower, machine capacity to perform the rework. So we have wasted resources, both upstream and downstream. Startup yield losses can occur when you have any type of startup. And this doesn't mean necessarily a new product or a factory startup. It means small startups. For example, you have a changeover. You have to restart the machine. Or you have shifts, just at the beginning of the shifts. It's the yield losses that occur right at the beginning of that startup then also would affect the quality of your parts and affect the quality rate. Now, let's look at all of these in terms of let's look at all of these in an example.